breakfast in Manhattan and a quick trip to London for lunch is no longer a movie plot.
GE Aerospace and Lockheed Martin just announced the successful testing of a new kind of air-breathing jet engine.
The military just finished a test flight that changes everything known about jet engines. They are using 3D printed parts to survive temperatures that would melt a normal airliner like wax.
When you fly in the atmosphere very fast, you generate friction, and that creates heat. And then you have to manage the heat.
This new hypersonic jet is the answer to a decade of failed tests and military anxiety. The race to dominate the sky is moving into a phase where speed is the only thing that matters. This is the start of a whole new chapter. Breaking reality in the Mojave. People used to think that enjoying breakfast in New York and being in London 90 minutes later was just a story for movies. But this is the future that is starting to happen right now. American aviation has a history written by bold moves and a hunger to own the skies. In the hypersonic era, being brave is not enough. It takes perfect math, tough materials, and a vision that goes beyond normal physical limits. This is a total change in how heat and air work together. A company called Hermeus is leading the fight with the quarter-horse prototype. The main goal is to shrink the world and change what speed means. As the world moves through 2026, looking back at the last 2 years shows that the military sky has changed forever. What was only on paper in 2023 has now left massive shockwaves across the Mojave Desert. The race is no longer about who can do it, but who will own it completely. To understand how intense this is, one must look at the global map of the mid-2020s. The idea of a hypersonic gap was once a nightmare for the Pentagon. While other countries put out missiles like the Zircon, the United States had a hard time with tests that did not work. Normal defense systems like Aegis were almost useless against things moving at Mach 5. The need for a vehicle that could scout, hit, and get out faster than any missile became a must-have for national safety. United States missiles and spaceships hit high speeds a long time ago, but keeping that speed inside the air for a normal flight was a goal no one could reach. The difference is the environment. A space capsule only goes through the air for a little bit during re-entry. It handles high heat for a few minutes. In contrast, a hypersonic plane has to sit in a thermal fire for hours. At Mach 5, the nose of the plane feels temperatures up to 3,000 degrees Fahrenheit. At that heat, aluminum would melt like candle wax. Even titanium starts to lose its strength. This is a problem humans spent 50 years trying to solve. It is why the team turned to 3D printed alloys and advanced ceramics. If someone looks back at the Concorde, it was an engineering legend. But its top speed was only about Mach 2, which is slow compared to the Mach 5 goal of the new era. That legend has been gone for over 20 years. The end of the Concorde did not just happen because of high costs, but because of the limits of 20th century tech. Its engines were great, but they could not beat the heat walls of old turbine designs. When flying faster than Mach 2.2, the air coming in would destroy the engine stages. The Concorde was stuck. It was too fast for regular planes, but too slow to start a real-time revolution. Power gaps never last long, and Hermeus does not just want to replace the old planes, they want to break the old records. The target is New York to London in only 90 minutes. For comparison, the Concorde needed almost 3 hours. For the team of engineers from places like SpaceX, that was not good enough. They brought a fast-moving mindset into a military world that is usually very slow. Instead of spending 10 years on papers and computer models, they chose to build real hardware and test it until it broke. This is how SpaceX learned to land rockets, and now it is being used to own the atmosphere. Their vision goes beyond the air, but for now, the priority is owning the sky at speeds that seem impossible. Things get even crazier when looking at how this new jet plans to beat the most famous spy plane in history. The beast that breathes fire. When people talk about the SR-71 Blackbird, they are talking about a legend that cannot die. The speed record of 2,193 miles per hour, set in 1976, still stands like a mountain no one has climbed in 50 years. The Blackbird was a masterpiece made of titanium and old-school engineering. But the quarter horse of 2026 is a beast made of ceramics and artificial intelligence. It was not born just to fly faster, but to fly easier and for much less money. To get out of the shadow of the Blackbird, the team created the Chimera engine. The name comes from a mythical beast, and it is a perfect fit for this hybrid monster. The Chimera is a special engine that combines 3 different technologies. It uses a turbojet, a ramjet, and a scramjet. The big problem in engineering is that a turbojet works great for taking off, but it loses power before Mach 3. Ramjets and scramjets are kings at Mach 5, but they are useless when moving slowly. The Chimera engine forces them to work as a team. It is like driving a fast car where the turbojet is the low gear that gets the car moving. But once the jet hits Mach 3, the spinning parts of the turbojet become a problem. It is like trying to pedal a bike while going down a steep hill at 60 miles per hour. At that point, the jet has to shift to a different mode while moving as fast as a bullet. This is a massive challenge. The system has to move the super hot air away from the sensitive turbine parts and straight into the ramjet. This turns the complex engine into a simple tube burning fuel. This transition is very dangerous. If the turbine shuts down too early or the ramjet starts too late, the plane loses all power and falls like a stone. Instead of spending billions starting from zero, the team used a smart strategy. They used engines that already existed to help with testing. This saved years of work. In November 2022, they hit a huge goal by switching from turbojet to ramjet mode on the ground. This opened the door for hypersonic planes that can be used over and over. This test happened in a special lab that simulated Mach 4 conditions. It proved the engine could switch modes without choking on the air. The first prototype used a General Electric J85 engine, which is a very tough engine that has been used for millions of flight hours. But they needed more power for the next step. For the Chimera 2, they picked the heart of the F-15 and F-16 jets, which is the Pratt & Whitney F-100 engine. This engine is a legend with over 30 million hours of flight time. They chose it because of its size and power. The F-100 lets them use a better pre-cooler, which is the secret to their success. At Mach 3 and above, the air entering the engine can heat up to 800 degrees Fahrenheit. Without cooling, the parts inside would melt instantly. Their pre-cooler acts like a miracle radiator that drops the air temperature in a split second. They use special 3D printed metals to make this happen. This lets the engine run much faster than it was ever designed to go. It is a local success that is moving faster than any other project in the world. What most people do not realize is that this speed is about to change how the military fights wars forever. Machines that rule the night. The race to Mach 5 is not for people who move slowly. The F-100 engine is a veteran, but raw power is not the only thing needed. The team has made their own parts, like the pre-cooler and the bypass system, to create the next generation of flying platforms. These goals are very clear. The first project is a drone called the Dark Horse. It is made for the extreme needs of national security. The Dark Horse is more than just a scout plane. In the new military plans for 2026, it is a jet that can fly across oceans to hit targets. Flying at the edge of space, it is too high and too fast for most current missile defense systems to hit. In places like the Western Pacific, the Dark Horse is the plane that kicks down the door. At Mach 5, it can take off from a base in Guam and reach the South China Sea in less than 30 minutes. It can blind enemy radars or hit targets and get away before anyone can even press a button. The military sees the Dark Horse as a high-end partner for the newest fighter jets and bombers. In a real scenario, a stealth bomber might fly slowly and quietly, while the Dark Horse screams ahead at Mach 5 to clear the way. This creates a massive problem for any enemy. While the military work is happening, there is also a project called the Halcyon. This is a commercial plane that promises to fly on over 100 transoceanic routes. It would travel 5 times faster than any jet today. But the Halcyon has a bigger challenge than the military drones. It has to handle the human factor. The forces felt during acceleration must be controlled so passengers do not pass out. Also, the loud noise made when breaking the sound barrier is a big legal problem. The team is working with NASA to design a plane shape that breaks up those shock waves. The goal is to turn a deafening crack into a soft thump so it can fly over cities. They expect ticket prices to be about the same as business class, but with 80% of the travel time saved. Every long journey starts on the ground. In early 2024, they finished testing the quarter-horse Mark 0 in Tennessee. In only 37 days, it passed all its checks for remote control and moving on the runway. The Mark 0 is a steel bird that never flies, but it let the engineers practice every move. This helped them make sure that when the real plane was built, everything would work. At these speeds, even a tiny delay in a command could send the plane a half-mile off course. Their development speed is as fast as the jets. They designed and built the Mark 0 in just 6 months. Right after that, the Mark 1 was shown to the world. A new rule has been set in the industry to build one new prototype every year. By the end of 2024, the Mark 1 was ready to leave the ground at Edwards Air Force Base. The world watched as the calendar turned to a date that history will remember forever.
New York to London for lunch. On May 27, 2025, the quarter-horse Mark 1 transitioned from simulation to reality at Edwards Air Force Base. This remote flight validated a double delta wing design, proving the startup's aerodynamic models were virtually flawless. While the Mark 1's primary mission was mastering the high-speed takeoff and landing cycles required for hypersonic flight, the data harvested throughout late 2025 provided a goldmine for refining flight software. The focus has now shifted to the Mark II, a more formidable platform comparable in size to an F-16. Supported by a private heat testing facility in Florida capable of simulating extreme hypersonic pressures, engineers have pushed the engine to its limits on the ground. As of January 2026, the Mark II is stationed at Spaceport America in New Mexico, prepared for high-performance trials. Built to withstand intense thermal loads with specialized shielding, the Mark II aims to hit Mach 2.5 and sustain supersonic flight without a pilot. Success in these early 2026 tests is the final hurdle before integrating the ramjet system, marking a definitive leap toward operational hypersonic technology. Things are moving fast, and hands down, the next few months will show if we are truly ready for the hypersonic age. What do you think about this Mach 5 goal? Will people ever really fly on commercial jets at missile speeds, or is this just for the military? Leave a comment with your thoughts. Make sure to like and subscribe for more top secret files. Thanks for watching.